Morning everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover linear differential equation with constant coefficients, which is second and higher order. In that, we discuss non-homogeneous terms of type 1 and non-homogeneous terms of type 2 to find the particular integral. So, this is a differential equation of the form a0 into d power ny by dx power n plus a1 into d power n minus 1 by dx power n minus 1 plus and so on an into y equal to x. This equation is called linear differential equation with constant coefficients. Here a0, a1, a2 and so on an are the constants, and capital X, this right side function, is some function of x. This differential equation can be written in the form of f of d into y equal to x, where capital D means d by dx, capital D square means d square by dx square, and so on, right? To find this, we find the general solution of this equation f of d into y equal to 0, that we call it as complementary function. If this right hand side in equation 1, if it is not equal to 0, then we call it as non-homogeneous linear differential equation with constant coefficients. Now let us see how to find the solution of this homogeneous or non-homogeneous differential equation. First of all, let us find the auxiliary equation, which is given by f of m equal to 0, right? After writing the given equation in the form f of d into y equal to 0, let us write the auxiliary equation given by f of m equal to 0. First, let us find the solution of this equation f of m equal to 0. If there are n power equation, we get n roots. If there is a second degree equation, we get 2 roots. If there is a third degree equation, we get 3 roots, right? So general solution is given by like this. Case 1, if all the roots are real and distinct roots, then this is how we write the solution for the differential equation. Suppose if m is equal to 1 comma 2, I am taking only 2 roots, both the roots are real roots and different roots. Then how to write the complementary function? C1 e power m1x, this is m1, so 1 into x, plus C2 e power m2x, m2 means 2, so that is 2x, right? Second, if two roots are real roots and equal roots, say for example m is equal to 2 comma 2, 2 is repeated 2 times, so we write the complementary function as c1 plus c2x into e power mx, m means 2, so we write 2x. Suppose if this same root is repeated 3 times, 2 comma 2 comma 2, right? Then we write the complementary function as c1 plus c2x plus c3x square into e power mx. What is m here? 2, so 2x. This is how we write the solution if the roots are real and repeated roots, right? Next, if 3 roots are real and m1 equal to m2 equal to m3, and remaining roots are different roots. Say for example, if this is any fourth root, then we write another root c4 into e power 4x. If these are the real and distinct roots, what if the roots are complex roots? So a plus or minus ib or alpha plus or minus I beta. So this is the formula to write the complementary function if the roots are complex roots. If these two roots are complex roots, then we write the complementary function like this. And to find the particular integral, there are different cases or different types. First type is type 1. If the function is exponential function e power ax, then we write the particular integral as 1 by f of d e power ax. In place of d, write down a, put d is equal to a, we get 1 by f of a into e power ax, provided this f of a denominator value must be not equal to 0. If the denominator is 0, it will be infinity, right? We don't find any solution. In case of failure, there are few problems where f of a will be 0. If this equal to 0, how to find the particular integral? So x into 1 by f dash of d e power x. You just multiply numerator with x and differentiate denominator f dash of d. Again substitute d equal to 0. If f dash of a not equal to 0, suppose if it is 0 again, you multiply again numerator with x and differentiate denominator. Then substitute d equal to a and so on. Right. Let us see one example. Solve d square minus 4d plus 13 into y equal to e power 2x. So first let us find the complementary function. For that we require auxiliary equation which is given by f of m equal to 0. This equation is in the form of f of d into y is equal to e power 2x. Here f of d means d square minus 4d plus 13. F of m equal to 0 means m square minus 4m plus 13 equal to 0. So what are the roots for this? There will be two roots. So m is equal to minus b plus or minus under root of b square minus 4ac divided by 2. So we get two roots as m equal to 4 plus or minus 16 minus 52 is 36. Root of minus 36 is 6i divided by 2, which is given by 2 plus or minus 3i. So this is alpha, this is beta. So the complementary function is given by e power alpha x c1 cos beta x plus c2 sin beta x. In case the roots are complex roots, this is the formula. Substitute alpha equal to 2, beta equal to 3. So yc is given as complementary function is e power 2x into c1 cos 3x plus c2 sin 3x. Right. Now let us find the particular solution or particular integral. So 1 by f of d means d square minus 4d plus 13. The function is e power 2x. Whenever this function is e power ax, to find this particular integral, put d is equal to a. Here a means 2. So substitute d equal to 2. We get 1 by 4 minus 4 into 2, 8 plus 13 e power 2x. This is e power 2x by 13 minus 4 is 9. Therefore, we write the general solution of the given differential equation as complementary function plus particular solution or particular integral. Complementary function is this one, particular integral is this. You add both the equations, we get the general solution. So e power 2x into c1 cos 3x plus c2 sin 3x plus e power 2x by 9. This is the solution for the given differential equation. Right. Let us see one more example. Solve d square plus 6d plus 9 into y equal to 2 e power minus 3x. So this is in the form of f of d into y is equal to 2 e power minus 3x. First, what is the auxiliary equation? F of m equal to 0. So in place of d, write down m square plus 6m plus 9 equal to 0. This can be written as m plus 3 whole square equal to 0. Right, m square plus 6m plus 9. Right. So we got two roots. M is equal to minus 3 comma minus 3. Both the roots are repeated and equal roots and real roots. So we write the complementary function as c1 plus c2x e power minus 3x. Now to find the particular integral, 1 by f of d, that is d square plus 6d plus 9. The function is 2 e power minus 3x. Now substitute d is equal to minus 3. If the function is exponential function, we have to find d equal to, we have to substitute d equal to a. So substitute d equal to minus 3, you get denominator value 0, right? If you get denominator 0, what you have to do? You have to multiply this numerator with x and differentiate denominator. D square plus 6d plus 9, if you differentiate it, we get 2d plus 6. So this is, now again substitute d equal to minus 3. So we get particular integral as 2x e power minus 3x divided by 2 into minus 3 minus 6 plus 6. Again you are getting 0 here. So again if you get denominator 0, you multiply this numerator again with x. So we get x square. Again you differentiate this denominator. So we get 2. So 2 get cancelled. This is the particular integral, right? So what is the general solution? Y is equal to yc plus yp. Add this complementary function and particular integral. This is how we find the general solution for non-homogeneous terms of the function which is of exponential function. Let us solve this one more example. Solve d square plus 2d plus 1 into y equal to e power minus x. So the auxiliary equation is f of m equal to 0, that is m square plus 2m plus 1 equal to 0. So you know that this can be written as m plus 1 whole square equal to 0. So m is equal to, there are two roots, minus 1 minus 1. So we write down the complementary function as c1 plus c2x e power mx. M means minus 1. So minus 1 into x. Let it be equation 1. Now to find the particular integral, 1 by d square plus 2d plus 1. The function is e power minus x. Now if you substitute d equal to minus 1, this denominator you are getting 0. So what you have to do? You multiply this numerator with x and differentiate the denominator. What is the derivative of d square? 2d plus 2d derivative 2 plus 1 derivative 0. Now again you substitute d is equal to minus 1. So minus 2 plus 2 0. Again you multiply with one more x in the numerator. Again you differentiate denominator. 2d plus 2 derivative is 2. So this is the particular integral. Therefore general solution is y is equal to yc plus yp. Add these two. Yc means c1 plus c2x e power minus x plus x square e power minus x by 2. This is the general solution. Now for non-homogeneous times of term 2, this right side function is of either sin bx or cos bx. We have to substitute, put d square equal to minus of b square, right? For example, if you substitute d square equal to minus b square, to find the particular integral, 1 by f of d square and sin bx. Suppose if sin bx is there and if you are getting denominator 0, that is f of minus b square, actually it should be not equal to 0. Suppose if you get 0, the particular integral is minus x by 2b cos bx. This is the formula. And to find the particular integral of 1 by f of d square cos bx, similarly the case, failure case, if f of minus b square is 0, then we get x by 2b sin bx. These are the two failure cases, right? Now first let us find the complementary function. What is the auxiliary equation? M square minus 3m plus 2 equal to 0. So this can be written as m minus 1 into m minus 2 equal to 0. So we get two roots, 1 comma 2. Both are real roots and different roots. So to write the complementary function, c1 e power 1 into x plus c2 e power 2x. Let it be equation 1. Now to find the particular integral, 1 by d square minus 3d plus 2. The problem is cos x, cos 3x. What is the procedure? Put d square equal to minus of 3 square, which is minus 9. It's not minus 3 whole square, minus of b square. So b means 3, so minus 3 square. Only in place of d square, forget about d, right? So 1 by minus 9 minus 3d plus 2 cos 3x. So this can be written as cos 3x by minus 3d minus 7. So this is cos 3x, take it minus common, by 3d plus 7. We have to get only d square terms in denominator. If we get d terms, we don't have any procedure, and if the function is sin bx or cos bx, so we have to rationalize to get a d square terms in the denominator, right? So this can be written as 3d minus 7 into cos 3x by 3d plus 7 into 3d minus 7, right? So this can be written as minus of 3d minus 7 cos 3x by 3d plus 7 into 3d minus 7, that is a square minus b square, 9d square minus 49. Now we got d square terms in the denominator. Again substitute d square equal to, again put d square equal to minus 9. So what is the particular integral? Minus of 3d of cos 3x minus 7 cos 3x by 9 into d square means minus 9 minus 49. So this is equal to minus of 3 into, what is derivative of cos 3x? Minus 3 sin 3x, isn't it? Minus 7 cos 3x by minus 81 minus 49, minus 81 minus 49 minus 130. So minus 130. So minus minus cancel. This is equal to minus 9 sin 3x minus 7 cos 3x by 130. Therefore y is equal to yc plus yp. What is the yc we got? c1 e power x plus c2 e power 2x. If we take minus common, 1 by 130 into 9 sin 3x plus 7 cos 3x, right? Let us see one more example. Solve d square plus 9 into y equal to cos 3x. First let us write down the auxiliary equation, which is given by f of m equal to 0, that is m square plus 9 equal to 0, which is given by m square equal to minus 9. So m is equal to plus or minus root of minus 9 is 3i. So we write the complementary function yc as e power alpha x, alpha means 0, into c1 cos beta x, beta means 3, so c2 sin beta x, that is sin 3x. Let it be equation 1. Now To write down the particular integral yp, consider 1 by d square plus 9 cos 3x. What is the procedure? If the function is sin bx or cos bx, put d square equal to minus b square, that is minus of 3 square. So if you substitute d square equal to minus 9, minus 9 plus 1 plus 9 becomes 0. If denominator getting 0, the failure case, what is the formula? For particular integral, if the function is cos bx, the x by 2b sin bx. This is the formula to find the particular integral if the function given is cos and denominator you are getting 0. Here b means what? Substitute b means 3. So x by 2 into 3 sin 3x. So this is x by 6 sin 3x. Therefore, general solution formula is y equal to yc plus yp. Add the particular complementary function and particular integral. So y is equal to c1 cos 3x plus c2 sin 3x plus x by 6 sin 3x. This is how we find the general solution, right? Thank you.